Today we are going to practice more questions on covalent bonding.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel Acad Shala. This gives us a lot of motivation to keep creating these kind of videos for you all.
The first question we are going to do it, the formation of chlorine molecule, that is Cl2. The atomic number of chlorine is 17. So what we will do, first of all, the first step, what we are going to do is we will write down the electronic configuration of chlorine. That is 287, that is KLM shell. And of another chlorine also we have written. It is not compulsory that twice you have to write it, just to make you understand. That is why I am writing over here. But only once it is more than enough to write. Now children, again, I would like to revise with you, as I told you in my previous video also, that you have to note this very important thing to solve this type of formations. That if there is one pair or two electrons, so the bond formation will be that a single covalent bond. If there are 4 electrons or 2 pairs, it will be double covalent bond. If there are 6 electrons or 3 pairs, it will be triple covalent bond. This thing you have to keep it in mind and always write in your rough hand side corner, that is on the right hand side, to solve this type of questions of formation. Now let's move further. Now we know the electronic configuration of chlorine. So that means we have to work only and only on the valence electrons. Always remember children, the formation whenever we do it, we have to work only on the valence electrons. That's all. So what we are going to do it now? This chlorine atom says, atom, I'm saying atom. That means out of chlorine molecule, I'm talking about this atom only now. This atom says that I need one electron to attain the stable gas configuration. This chlorine also is having the same problem, that I also need one electron to attain the stable gas configuration. So they both decide that let us give one electron for sharing. They say if we do the sharing part, we will be benefited and we both will attain the stable gas configuration. So they both decided. So what this chlorine did, now I'm going to show it on the board. Now this chlorine says that I will share my one electron and I will keep my these 6 electrons outside. Okay. So now children, remember that out of this 7 electrons which are valence electrons, out of these 7 electrons, 1 electron this chlorine has shared it, right? Now this chlorine says, okay, I will also share my 1 electron and I will keep my 6 electrons outside. So he also did the same thing. Fine. Now they say, now let us check that whether I have received 8 electrons or not. That means I have attained the stable gas configuration or not. This chlorine also says that I will also check. So this chlorine says, let me check. So, and this chlorine says, let me check. So now this chlorine says, I have 1, 2, 3, 4, 5, 6, 7, 8. Yes, I have attained the stable gas configuration. This chlorine says, let me also check. 1, 2, 3, 4, 5, 6, 7, 8. Yes, I have also attained the stable gas configuration, which I have shown you over here previously only in this diagram. After this, the next step and the final steps comes about the bond formation. We have to work only on this sharing of electron part. I have seen that there are 2 electrons. That means 1 pair. 2 electrons of 1 pair meaning is the same. So that means it will attain the single covalent bonding. So I will put a single line over here which shows a bond and hence justified it is single covalent bond. Is this thing clear, children? Please keep on practicing. Now let us come to the next one. Okay. Now the formation of methane. Now formation of methane, before that, always remember children that you should know the chemical formula, which is really very important. Otherwise, it will be a problem for you to solve it if you do not go for the chemical formulae and the valency and the symbols and so on and on. Am I clear? Okay. Now, again, what we will do, we should know this. This is the first thing. Now, what we are going to do it right over here, that I will write carbon over here. What is the atomic number of carbon? 6. Okay. What is electronic configuration of carbon? That is 2, 4. That is, this is K shell and this is L shell. Right, children? Okay. After this, now what is the atomic number of hydrogen? Atomic number 1. Electronic configuration 1. We have K shell. That means we have only and only one shell, that is the valence shell, K shell. We have two shells, that is KL, and we have to work from this two shells, that is only in the outermost shell, that is the valence electrons. Valence electrons in carbon are 4. Valence electron in hydrogen is 1 only because it has one shell only. Okay, now what this carbon says, okay, I have 4 hydrogens. So this carbon says that I have to be in the middle and these hydrogens will come on my 4 sides. So he says, carbon says, please come on my 4 sides. So these hydrogen says, okay boss, we are coming on its 4 sides. So they stand over here. Now, this hydrogen says, I have only and only one electron, so I would like to share it. One electron. This hydrogen says, I will also share. This hydrogen says, I will also share. This hydrogen says, I will also share. Why they are sharing? Because this hydrogen wants to attain the stable gas configuration, but in the form of duplet. Why? Because it has only one electron, which I told you in the previous video. So if it attains one electron or shares one electron, it will attain a stable gas configuration, that is duplet state, because hydrogen is the only one who attains stable gas configuration in the form of duplet, that is stable gas configuration helium. Okay, after this, now this carbon says, okay, I have 4 electrons in my outermost shell. I will also share one electron with hydrogen to attain my stable gas configuration, that is octet. So carbon says octet and hydrogen says duplet, and both the things are satisfied by sharing its 1 electron each. More than enough. So now what happens? So they will again see that this hydrogen says, let me check whether I have attained my duplet, that is stable gas configuration. Okay, then this hydrogen says, let me check. 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 Okay, and after this now carbon says, let me also check. Okay, now this hydrogen says, I have attained 2 electrons, stable gas configuration. This hydrogen says, yes, I have also attained. This hydrogen says, yes, I have also attained. This hydrogen says, yes, I have also attained. That means this hydrogen has attained the stable gas configuration, that is duplet. Now, carbon's turn. Carbon says, let me check also. Carbon says, 1, 2, 3, 4, 5, 6, 7, 8. Yes, I have attained my octet, that is stable gas configuration 2. So this is all done, which I've shown you over here in my previous diagram. Okay, after this, the last step, final step is the bond formation. Now I will see in my this sharing of electron part, how many electrons are there. In this sharing of electrons, 2. In this 2, in this 2, in this 2. So 2 electrons of one pair means single covalent bond. Of course, I have come to know what I will do. I will put this bond over here and I have shown my formation of bond over here. So this is single covalent bond. This is also finished. Now the last is formation of carbon dioxide molecule. Again the same thing. This you should know. The first is carbon, atomic number 6, electronic configuration 2,4, Kl shell. Oxygen, atomic number 8, electronic configuration 2,6, Kl. We have to work only on the outermost shell, that is the valence shell, that is the valence electrons. We have to focus only on the valence electrons. Now, we know carbon contains 4 electrons, as I told you, in the valence shell, and it requires 4 electrons to complete its octet. While oxygen, that means contains 6 electrons in its valence shell, and it requires 2 electrons to complete its octet. Carbon may complete its octet by sharing 2 electron pairs with 2 oxygen atoms, forming, that is, 2 double bonds. The formation of carbon dioxide molecule is shown below over here, which we are going to now study in detail how it comes. Okay, now see. Carbon is over here and oxygen on its sides. Okay. Now oxygen says I have to attain 2 electrons. So what I should do? Out of these 6 electrons, I will share my 2 electrons. So this oxygen says I am giving my 2 electrons. And how many are left? 1, 2, 3, 4. And this oxygen says I'm also sharing my 2 electrons. And how many left? 4. 1, 2, 3 and 4. Why 4? Because out of 6, 2 electrons are shared. And when 2 electrons are shared out of 6, so 6 minus 2, 4. So that is why 4 I have kept outside this oxygen. Am I clear? Okay. After this, carbon says, okay, I also have to share. I have 4 electrons in my outermost shell. What I will do, I'm very specific. I will give 2 electrons equal to both my oxygen atoms because both are equal for me. So this carbon says I am giving 2 electrons to this oxygen and 2 electrons to this oxygen. And I'm done. So now after this, they say, let me check about its octet state. Oxygen says, first let me check. So this oxygen says, I'm checking. So this oxygen says, I am checking. And this carbon says, I will also check. Okay. Now, this oxygen says whether I have achieved the stable gas configuration, that is octet. Let me check. 1, 2, 3, 4, 5, 6, 7, 8. Yes. This oxygen says 1, 2, 3, 4, 5, 6, 7, 8. Yes. And this carbon says 1, 2, 3, 4, 5, 6, 7, 8. Yes. We both, and carbon says I also have attained the stable gas configuration. Again the same thing, the last part and the final part, we have to do it. Now I will see that in the sharing part, how many electrons I have. In this sharing part, I have 4. In this sharing part, I have 4. That means 4 electrons or 2 pairs makes a double covalent bond. So what I will do, I will write C in the middle and double bond O and double bond O. So this makes the formation of carbon dioxide molecule, which is a double covalent bond. Finished. So this is all about your formations. The practice, you have to do it on your own again after my video gets over. This is very important, children. That is why I've kept a book over here where I've written revise. That means you have to revise every time. It is not that after watching video you are done. No. After watching video, after some time, after 3-4 hours, please do it on your own with your pen on the paper. Please do not do oral. You have to use your pen and paper to practice. Oral work will not help you ever. So I'm very clear about it, children. Practice makes a man perfect. Only practice will make it wonders in your exam. So with this, I wind up the session. Thank you. Bye-bye. God bless. Take care.